In our last lesson, we talked about what the characteristics of a parallelogram are. There were 5 things that we know about every parallelogram. Today, we're going to shift gears and we're going to turn it kind of backwards. We're going to say if a quadrilateral has these characteristics, then it is a parallelogram. So, we're going to start this with a quadrilateral is a parallelogram if. And I'm going to give you 5 things that make a quadrilateral a parallelogram. And they're going to sound a lot like the ones you learned last lesson, but there's one that's different, so you want to pay close attention. Well, the first one is, if my quadrilateral has both pairs of opposite sides parallel, then it is a parallelogram. That was the definition of a parallelogram, if both pairs of opposite sides are parallel. The next one says, if both pairs of opposite sides are congruent, then it's a parallelogram. The next one says, if both pairs of opposite angles are congruent, then it's a parallelogram. And that, again, these all sound like the lesson from the previous class. This one says if the diagonals bisect each other, then we have a parallelogram. So those 4 are identical to the ones that were on our list from last class. Here's the one that's different, so you want to pay close attention to this one. If you have one pair of opposite sides congruent and parallel, one pair of opposite sides that are both congruent and parallel, then you have a parallelogram. So what that looks like is I've got one pair of sides that are congruent and that same pair of sides is also parallel. That is a parallelogram. Sometimes you'll see a picture that looks like this. It'll have one pair of opposite sides congruent and a different pair of sides parallel. That is not enough information to make this a parallelogram. That picture could be a trapezoid, so we don't know for sure that it's a parallelogram. So this is the one that's different, so you want to pay close attention to it. The other 4 come straight from this list right here. The only one we don't use is consecutive angles or supplementary is not enough information to prove that it's a parallelogram. So consecutive angles or supplementary could make it a trapezoid. So we don't know for sure that that would be a parallelogram. So let's look at some practice examples to see how this works in real life. So our first example, this is the day 2 pictures. Notice we have this pair of sides is congruent, and they gave us these 2 angles. Well, remember that last rule that said one pair of opposite sides congruent and parallel? We want to make these parallel to each other. So the way we do that is we check these same side interior angles, and we need to make them supplementary. So we're going to take 2x plus 20 plus x plus 10 equals 180. Because if this is going to be parallel, the consecutive interior have to be supplementary. So that's 3x plus 30 equals 180, and then we'll solve it. X is 50. So in other words, if this angle is 120 and this angle is 60, that's enough information to say these 2 lines are parallel. And now we have one pair of opposite sides that is both congruent and parallel. That is enough information to make it a parallelogram. All right, let's take a look at the next one. This one, it looks like they're asking us about the diagonals. So they've already told us that these 2 segments are equal. And one of our rules had to do with the diagonals bisecting each other. So remember, that didn't mean that they cut angles in half. That meant that the diagonals cut each other in half. So if I can make these two segments equal, then I'll have the diagonals bisecting each other. So 4x plus 2 equals 5x minus 6, and we solve for x. And that makes this segment, let's see, 32 plus 2 is 34. 40 minus 6 is also 34. So that one is if the diagonals bisect each other, then we have a parallelogram. Now, since the title of this lesson is technically proving parallelograms, guess what we're going to do next? We're going to prove that something is a parallelogram. So we're going to prove that ABCD is a parallelogram. We need to make one of these 5 things true in order to complete our proof. So we're going to have to look at our given information and decide which one of these is going to be the easiest thing to prove in this picture. I don't see any diagonals drawn, so I might not use that one. I don't know if I can do the angles. It might have to do, I'm not, let's see what it has to do with. Now, first off, they told us that DEBF is a parallelogram. So once they tell us that something is a parallelogram, we know that these 5 characteristics are automatically true. So I can use any one of these or multiples in my proof about DEBF, because that's the one we know is a parallelogram. And they also told us that AE was equal to CF. So let's write that down in our given, and we'll kind of plot out how we're going to do this. And if you don't want to write the word parallelogram, you can draw yourself a little picture. It doesn't have to be perfect, but just to get the idea that it's a parallelogram. Okay, that's my given. I think I'm going to use number 5. I'm going to prove that the top and the bottom are congruent and that they're parallel. The parallel part, I already know. If DEBF is a parallelogram, don't I already know that these are parallel? I'm going to say that. DF is parallel to BE. And that was because the opposite sides of a parallelogram are parallel. Now, if DF is parallel to BE, isn't AB parallel to DC? I'm going to kind of put that in parentheses, because technically segment DF, and if you make it a line, line DF and line DC are the same line. So I'm going to kind of put those together. That works. Now, if only I could make the top and bottom congruent to each other. I think I can do that. Little segment addition is going to help us out here. So I know that DC is equal to DF plus FC. Remember, the big segment equals the little one plus the little one. And I say the same thing across the bottom. AB is equal to AE plus EB. That's my segment addition. Now let's see what we know. I know that FC and AE are congruent because they gave me that up here. Those are equal to each other. Now, what do I know about DF and EB? Remember that DEBF was a parallelogram, and in a parallelogram, the opposite sides are congruent to each other. So I'm going to say that DF equals EB because the opposite sides of a parallelogram are congruent. So I think since these are congruent and these are congruent, I'm going to go ahead and say that DC equals AB by substitution. Because we could do a couple of substitutions. We can substitute AE for FC, EB for DF, and that would make DC and AB the same thing. Now, I have one pair of opposite sides, parallel and congruent. So I'm going to make my final statement. ABCD is a parallelogram because it had one pair of opposite sides that was both congruent and parallel. Phew. So that's our lesson on how to prove something is a parallelogram. So just to refresh, remember we have the 5 characteristics of a parallelogram, and then we had 5 things that prove a parallelogram. One of these statements is different, and that's, you have to really pay attention to this one, because these you'll already know, but this one is different to prove that something is a parallelogram.